At AERZEN, since 1864, we design high-performance blowers, screw compressors, and high-speed turbo blowers for the industry. We introduced Europe's first positive displacement blower back in 1868. Since then, we have become a global player with over 50 subsidiaries around the world and more than 2,500 employees. Our goal is to redefine quality and innovation, so when you see an AERZEN name on a machine, you know exactly what you can get. You can expect performance. Hello, I am David Salazar, AERZEN Regional Application Manager for Pneumatic Conveying Applications. Welcome to this interactive presentation, which is meant for you and me to participate and learn from some real case scenarios related to energy, CO2, and cost reductions in the pyroprocessing for cement manufacturing. We're glad you've decided to join us in today's presentation. If you are willing to learn more about other applications or AERZEN services for the cement industry, you can also take a look to our specific application content in our YouTube channel. Cement manufacturing is a highly energy and emission-intensive process because of the extreme heat required to produce it. Producing a ton of cement requires 4.7 billion BTUs of energy and generates nearly a ton of CO2. Different types of fuels can be used to reach that needed temperature to produce clinker. All of them with its cons and pros for the process, as well for the environment. Thermal energy is the most important part of the burning process, as the material needs to reach certain temperature to guarantee the proper chemical reaction of the raw material components. Can you guess how high is the temperature needed to produce cement? If you select option C, you are correct. At that temperature, bilites and calcites are completely formed into the clinker rock and having the appropriate microscopical shape that will guarantee that after the final grinding, where we will see the cement powder, water absorption will be even along the particle, which finally determines the quality and strength of concrete. Have you seen some cracks in the road? One possible cause is a lower cement quality. Now that we know how important is the temperature in the kiln, let's see the possible materials that can help us reach that high temperature. Do you know what is the most used solid fuel used in the cement industry? If you selected option D, you are right. Coal has been the most popular fuel in the cement industry for a long time. A wide range of other fuels such as gas, oil, liquid waste materials, solid waste material, and petroleum coke have all been successfully used as a source of energy for firing cement kilns, either on their own or in various combinations. As we know, clinker is brought to its peak temperature mainly by a radiant heat transfer, and a bright and hot flame is essential for this. High carbon fuels such as coal, which produces a luminous flame, are preferred for kiln firing. Natural gas is in most places cheaper than coal. However, the availability can be confirmed, and cement plants cannot afford to limit their accessibility to the fuel. Another material that has been widely used is petroleum coke or petcoke, an oil subproduct with similar heat transfer as the coal, but with a considerable higher CO2 emission per ton burned. In our customers' plant, they mainly use coal as a primary fuel source. However, as coal prices have had some considerable price fluctuations over the past years, and availability to the material has become a challenge in countries where power plants fired by coal are a priority. In addition to this, the plant was going through an important expansion project to increase capacity from 3.2 million tons a year to the existing capacity of 5.2 million tons. Taking this into consideration, the cement plant decided to increase burning capacity and make it suitable for alternative fuels and petroleum-based type of fuels such as petcoke. The existing burner, suitable only for coal and heavy oil, only for the startup, was replaced with a burner suitable for gas, liquid and solid fuels from different characteristics to include alternative fuels. The process required an important investment on engineering and optimization of the existing equipment. Let's take a look at how AERZEN supports this project. Here is the technical data. At the same time the plant was replacing the burner, new operational conditions were required for the fuel conveying system that considers both the plant expansion project and the alternative fuel condition. As in most of the expansion projects within the cement plants, piping was required to keep the same length and nominal diameter, as complete replacement will require a more complex intervention with a longer downtime. Biggest challenge in this project was to avoid exceeding the 30 meters per second limit for the solid fuel conveying. We needed to take into account the pipe diameter as the biggest physical limitation. In this case, total equivalent pipe length was short, no longer than 20 meters, which was something good for our calculations. We didn't want to exceed the 30 meters per second in the conveying speed, as for this application, maintaining a laminar flow is critical to guarantee a stable and long enough flame size out of the burner, as it also plays a big role during the combustion and heat transfer process. Hybrid technology was a perfect fit for this application, as its internal configuration and higher rotation speed reduces air pulsations, making the air delivered smoothly and laminar. However, exceeding the air delivery to the pipe limit will cause a rupture on the Reynolds number and start making the air turbulent. We didn't want that, as it may result in an anticipated combustion and a shorter flame size that can even cause the burner tip to catch fire. Final decision was to use two D98S Delta hybrid units with over 60% more volume flow capacity and 30% more pressure capacity. All calculations were carefully made to avoid exceeding the 30 meters per second of air velocity in the pipe. Let's review the key takeaways from this case, where we replace a Delta blower with a Delta hybrid unit. First, 30% conveying capacity increase for coal or alternative fuels usage and 40% operational cost reduction, including energy savings for technology renovation and extended maintenance intervals using the hybrid technology. Second, increase laminar airflow delivery, which helps the stability of the flame and avoid burner tip to catch fire by giving more distance to the flame initial distance. And third, keeping the existing piping system having a chance of future expansion by just increasing hybrid speed and the solid fuel feeding valve. Thanks for joining us today in our interactive presentation. We hope you have enjoyed our journey through one of the most exciting processes in the cement manufacturing. If you have any further questions, I'll be happy to discuss it with you later. And make sure to contact your AERZEN entity in your region for any specific questions or local support you need from our team. Thank you. Expect performance. Expect performance. Expect performance.